Look at the night sky. There are an estimated 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. At its core, the sun burns at 27 million degrees Fahrenheit. The sun releases 384 septillion watts of energy every second. Yet, just a few hundred miles above your head, space sits at minus 455 degrees Fahrenheit, nearly absolute zero. If space were simply a frozen void, we would expect satellites to require heavy-duty heaters. Instead, engineers designed the International Space Station to constantly manage extreme heat. Astronaut spacesuits follow the same logic. They are equipped with internal cooling systems to prevent the occupant from overheating while surrounded by the blackness of space. Understanding why space remains cold in a universe of fire requires looking past our intuition and redefining what temperature actually is. The requirement for cooling systems in a sub-zero vacuum shows that thermal energy behaves differently once you leave the atmosphere. Temperature is not a property of empty space. It is a measurement of matter, specifically the average kinetic energy of particles. A hot object is particles jiggling. Absolute zero is the point where that motion drops to its theoretical minimum. This leads to a physical reality. If there are no particles to measure, there is no temperature. The density of matter makes the difference. A cubic meter of air on Earth contains roughly 25 quintillion molecules. In the voids between stars, that same cubic meter might contain only a single atom. Without those particles, conduction and convection are impossible. Heat cannot travel by touch or through a fluid medium like air or water. That leaves radiation. Electromagnetic waves are the only way for heat to cross the vacuum of the cosmos. Radiation does not heat the vacuum it travels through. These waves cross millions of miles of empty space without transferring any energy to the emptiness itself. Warmth is only created when that radiation hits something with mass, a planet, a moon, or a grain of dust. NASA's Parker Solar Probe provides the physical measurement of this mechanic. In 2021, it flew within 6.5 million miles of the sun's surface. The heat shield takes a direct hit from solar radiation, reaching 2,500 degrees. Yet, just inches away in its shadow, instruments operate at minus 238 degrees. Without air to carry warmth around the edges, this transition to a deep freeze happens within feet. The moon works the same way. On the lunar equator, the surface hits 250 degrees in direct sunlight. Step into the shadow of a crater, and the temperature drops to minus 290 degrees. Mercury is the closest planet to the sun, yet its night side is colder than the surface of Mars. Without an atmosphere to hold on to heat, the surface warmth bleeds immediately back into the vacuum as radiation. An object's temperature in space is determined by its relationship with radiation. The vacuum itself has no temperature to give. If the vacuum holds no heat, we have to look for the baseline that prevents the entire universe from hitting absolute zero. In 1964, astronomers discovered a persistent noise in their antenna coming from every direction in the sky. They had found the cosmic microwave background, the afterglow of the universe's birth. This radiation fills every centimeter of space with a temperature of minus 455 degrees Fahrenheit, and it continues to cool as the universe expands. The Boomerang Nebula is the only known place where gas expands so rapidly that it cools to just 2 degrees above absolute zero, colder than the background temperature of space itself. Space is cold because there is almost nothing in it to capture and hold heat. The sun's energy does not warm the vacuum, it only warms the objects it strikes. Earth is an exception. Our planet is wrapped in an atmosphere that absorbs, distributes, and retains the sun's radiation, acting as a blanket against the vacuum. The warmth we feel every day is a precise departure from a cosmos that is almost everywhere unimaginably cold. The mystery is not why the universe is freezing, but how warmth like ours exists at all.